We know the transportation revolution is being led by the likes of Uber and Lyft and will be driven by autonomous cars. But that's on the ground. How about in the air? That cloud-tipping topic coming up on Autoline this week. And now, here's your host, John McElroy.
I want to thank you all for joining us on Autoline this week. You know, in 1940, Henry Ford said, and I quote, "Mark my words, a combination of airplane and motor car is coming. You may smile, but it will come." And that's what today's show is all about. Not just having cars and autonomous cars coming in the future that drive on the ground, but drones, or what they call vertical takeoff or landing craft. And I've got three terrific people to talk about what's coming, including Bob Lutz, the former vice chairman of General Motors. Jon Rimenelli is the founder and CEO of a company called the Detroit Aircraft Corporation. And Robin Lineberger is the head of Deloitte's practice for aerospace and defense for the global industry. I want to thank all three of you for joining us here today. Robin, why don't I start with you?
Sure.
What's all this talk of having drones move people around? And you take it from there, please.
Sure. I think what you can see is a really the public is excited about when they see these personal drones flying around. It's not a far reach for them to imagine being in a bigger one and being able to go when they want, where they want, and being able to be taxied around, if you will, in a drone.
And this is coming.
It's absolutely coming. We're seeing prototypes built. We're seeing demonstration programs. They're flying as we speak.
What's been the change that has enabled this?
Yeah, I think the real change has been sort of the confluence or timing of technology, some of the key technologies. So as you see the basic, little, not toy, but private drones, personal drones, you can imagine they've figured out some of the battery technology from some of the automotive industry is happening at scale. They're looking at the engines that are much more efficient, looking at the geospatial technology with the readily available and accurate GPS. And then you're looking at the advent and then starting to accept the autonomous driving capability, in this case autonomous flying. We all know that we have autopilots today, and if you couple that with some of the automobile technologies and those software engineers can now put together or integrate the key technologies that are overcoming some of the traditional barriers of being able to do something that's pilotless.
Jon Rimenelli, you're actually starting to build one of these things, or tell us a little bit about your company and what your plans are.
Sure. Started the company in 2011 with this concept of leveraging the automotive industrial base to build low-cost aircraft systems that connect the nation's 15,000 airports. We, as a country, only use roughly less than 1% of the available infrastructure for air transportation, and that really seemed like sort of a great opportunity to solve that problem by mass-producing craft, make them affordable, and connecting those cities. Starting small, we started building unmanned aircraft systems for military, public safety, firefighters. Did fairly well. We worked with a very, very large defense company for about 3 years, and the writing was on the wall with the low-cost product coming out of China, and we just said, look, we're not going to, it's not worth it. Let's focus on mobility for cargo and passengers. So we took what we learned, escaped. We were able to sort of move on from small unmanned systems and apply our knowledge towards larger aircraft. Our aircraft currently is about 5,000 pounds, and we leverage validated existing EV technology from motors, battery management systems, control systems, and we essentially just repackaged it. And instead of using wheels, we use propellers. And so I like to say we don't reinvent the wheel, we just turn it sideways.
And we're going to get into more details, but we got to bring Bob Lutz into the conversation. A car guy through and through, as we mentioned, former vice chairman of General Motors, but you've always been a pilot.
Yep.
Marine fighter pilot. You've owned your own planes and helicopter.
Right.
What do you see this all doing?
Well, I like to believe I'm somewhat of a futurist, and I tend to anger people in the automobile industry when I say the era of car ownership and variously styled cars is all going to go away. It's going to be autonomous, normed, interconnected modules that nobody will own. And we'll see a lot less congestion in the city. This obviously, and this is in over a 30-year time frame, but it's going to happen by stages, and it's going to start happening at an accelerated pace 4 or 5 years from now. But and this angers people in the industry because it doesn't make the stock go up. But the way I see it is, John's absolutely right. We're not using three-dimensional space, and as Robin said, the same precision digital maps that are now being created for a lot of cars, they can be implanted in an airplane or a flying machine just as easily. And all of the sensors, the ground proximity sensor to start decelerating, it's all there. I mean, the technology is all available. It just has to be put together. And the military has been flying autonomous reconnaissance aircraft for probably about 20 years. I mean, I was a board member of Northrop Grumman when we did the Global Hawk, and that could fly autonomously from a base in California to a base in Australia, land itself, and taxi up to the reviewing stand with the generals in it. And the quadcopters today, again using the model of the little commercial ones that you fly to take pictures with, but it scales easily. And my point is, people say, yeah, but the batteries, they don't have to be battery powered. You could use a reliable, quiet, 4-cylinder, 200 horsepower gasoline engine just as well. But the quadcopter is stable, it's relatively silent, the blade speeds aren't as high as they are at the tips of a helicopter rotor. They're safe because the rotors are completely encased. And point-to-point travel is going to be much easier in these things, and the technology required for obstacle avoidance is going to be trivial compared to what you have to do for cars. On the highway, there's construction, flooding, pedestrians, fallen logs, all of this stuff that isn't in the precision maps. And that's where you need all these in-vehicle sensors to cope with new situations. Well, up in the air, there are no new situations, and you'll be able to go point to point. And I think, frankly, the automobile industry is showing huge myopia and saying, no, we don't do that stuff. If it doesn't have 4 wheels and travels on a highway, we're not interested. But they should be thinking mobility. Yeah. And the future is exactly what John is going to do here. And I want to see, I would very much like to see the U.S. get very actively involved in this, because if we not, as India and China are going to take it all.
Yeah. Robin, you see the same thing? This is going to be very disruptive to the automotive industry?
Well, I certainly think a part of it, right? As Bob and John have pointed out, the point-to-point travel, absolutely. It's being able to utilize the 3 dimensions of space unclogs the roads, so to speak. I do think, if you talk about what has to happen in order to start being able to scale and bring that alive, it's not too big a leap. There's some basic infrastructure that needs to be put in place. I wouldn't call it overly heavy. The ability for these the quadcopters and other, let's call them cooperating vehicles, to communicate where they are in 3 dimensions. The ability to integrate with the flight management system so that it's telling them, the theory would be, I'm going to tell them on my smartphone where I want to go. How do we get that up to a unified traffic management system so it knows its origination and destination and approximately how it's going to get there? The high bandwidth ability to communicate between the vehicles, and then, as Bob mentioned, the uncooperative objects that are out there, the birds, the balloons, and other quadcopters that can no longer, that have lost the ability, or there. Those sensors, the sensor technology exists, perhaps a little longer range type technologies than what exists today, but it's a fairly straightforward technology problem rather than being a literal barrier.
It's not trivial, but it's straightforward.
Yeah, right.
And nothing has to be invented. It just has to be engineered.
Is that how you see it, John? I mean, you're the manufacturer here.
So you made a great point about the automotives being sort of myopic about this. At the end of the day, what we're looking at here today is a huge problem around the world. Urban cities around the globe are experiencing gridlock traffic today. And fewer people have said it more elegantly than Bill Ford Jr., that traffic is no longer going to be a matter of an inconvenience, but it's going to be a matter of human welfare, and that people, food, and healthcare will have a very difficult time moving around if we don't do something different. So with that in mind, we're looking at a doubling of the population worldwide in urban centers from 2.3 to 5 billion. We're looking at a doubling of the number of vehicles on the road in the United States alone, from about 250 million to 500 million. So if we take that and we think about that in the context of the urban environments that are just in sort of gridlock today, I mean, we're going to have a major problem on our hands.
So how can your craft solve this? I mean, give us some examples of what the situation is today and what your VTOL will do for that.
So in general, the idea is to reduce the pressure off the roads, which means we have to have a lower concentration of vehicles on the road doing certain jobs. And whether the job is moving cargo or, you know, doing accident forensics or doing passenger mobility, what our plan is, and you know, our mission is to basically deliver an air vehicle which is simple, safe, and robust, that can facilitate cargo or passenger transport between, you know, the top 50 airports in the United States to a 60-mile radius and range around that airport. So essentially connecting airports, cities, and suburbs, which at the end of the day would reduce that pressure off the road. Now, we're looking at, according to Department of Transportation, NASA, 47% of all miles traveled on the ground will be replaced by VTOL transport.
So almost half of all traffic.
By 2030.
Wow.
By 2030.
That's around the corner. In automotive terms, that's just a couple of design cycles.
And that's when I see the total revolution to autonomous modules as opposed to the cars that we own and drive today. Yeah. And those will be, nobody's going to want to own one of these things. You just order them up, use it, and that's part of the solution to urban congestion as well. Right now, 90% of all cars on the road are not operating at any given time, right, but they're using up parking structures, parking spaces, and they're just clogging everything. That goes away. That alone will free up a lot of space. And I think John is looking at medium term when he says, well, we'll connect airports and suburbia, and that's maybe by 2030. But by 2040, 2050, it'll be an integrated thing to where you might take the first stage of your trip in an autonomous quadcopter, then switch for the last couple of miles to an autonomous module, which you will have booked from the same company on the same day, yeah, and you'll get the same bill, and part of it will be for air and part of it will be for road, and it doesn't matter. So they're all transported, and I'll tell you, people have so much trouble getting their heads around this, yeah, because they say, but I like to drive. I said, well, you'll have to sign up for a motorsports park like Monticello in New York and Autobahn and Concourse, Michigan Concourse and so forth. Then you can drive. It's going to be like dude ranches today and horse stables and horse racetracks. Right. You know, the people that love horses never got over it. And they have their own little world, and there'll be a world where you can actually drive a car for a day. But the rest of it is going to be, and the reason there's going to be a heavy demand for, it'll probably be more expensive. The vertical transportation will probably be a premium. That's because it's so much faster. Because the autonomous modules are all, there's going to be no passing, everybody's going to be in a train, mm-hmm, everything's going to move at exactly the speed limit. So if you're not in a hurry, that's fine. But if you are in a hurry, you're going to call the air taxi. That's going to get you point to point in like a third of the time.
Right. Exactly.
Right. Robin, Bob's talked about he really wants to see the U.S. get aggressive on there. Where does the U.S. stand right now, and how many other countries are getting into this vertical takeoff and landing VTOL technology?
Yes, right. So I think from a vehicle standpoint, it's pretty diverse. But I think what's interesting is, you know, what does it take to get there? That in the United States, for example, it's good to see that action has been taken. And I give an example that since 2013. NASA has been working with 6 test sites around the country. And what they've been doing now, while this is for the early stages of the commercial drone technology, as we were talking before, most of the infrastructure, sensors, those things that it's going to take to fly or manipulate, let's call it a commercial, and I say commercial, I mean a business use drone, package delivery, that sort of thing, medication delivery. It needs the basic infrastructure it would take to fly these quadcopters with people in them as well. And so seeing that prove out how these flight management systems are being integrated, how the unified management systems are being done, how the current technologies around data communications amongst themselves, the ability to operate autonomously with other vehicles around you, that's been going on since 2013 and has been quite successful.
Okay, so NASA's involved. Who else is involved?
Well, you've got the commercial companies that would be the ones that will then create
Somebody
and
like
sell.
Amazon's been talking about it for years.
Well, certainly as a user of it,
Sure,
but then you would see some of the traditional aerospace and defense infrastructure builders, those that do air traffic management today, are looking at they see this as an opportunity. So they're investing their time and equipment, their software and others, so that creates a market for them. As this were to deploy, then they'll become the fundamental providers of it.
What about the regulators, the Federal Aviation Administration? Because I got to believe there's going to be a lot of regulation with this.
Absolutely, the FAA is involved. In fact, they're the ones that are licensing the airspace and working through helping develop the various scenarios that it takes, the different use cases.
But I think the FAA generally likes aviation, and they will try to enable as opposed to try to block. And that's what the wonderful thing about our FAA as opposed to the equivalent organizations in other countries, where every airplane that takes off is seen as a personal defeat for the agency. Right. Whereas the FAA guys, I don't think are going to be a holdup.
Well, one of the things that's really helped is, if you think there's a concept in our FAA called Next Gen, which is in a sense, call it the digitalization of the air traffic management system to reduce the reliance on the system of having people in a tower talking to pilots to try to tell them where to go.
And that's fairly soon that the United States is going to get that,
Technology is mandated by 2020 in any commercial passenger aircraft and freight aircraft.
So just to touch on that, there's 2 pieces to your question to Robin here. One was traffic management, and 2 is regulation. As he mentioned that the FAA and NASA had been working since 2013 to sort of begin testing what was referred to as unmanned traffic management systems. 2012, President Obama signed the Next Gen bill, which is to modernize the national airspace system using GPS for tracking and to facilitate approaches and arrival. And that's supposed to make it, the large airlines more efficient to go in and out of these big hub and spoke. But that system really isn't designed for drones and for us because it'll clog the ATC, air traffic control screens. So my whole position has been, for the last 2 years, we actually have an agreement with the US DOT to test a new traffic management system based on an automotive technology. So V2V, V2X is, there's
V2V being vehicle to vehicle.
Right, so that's based on what's 802.11c P protocol, which is DSRC. That's, vehicle to vehicle communication system is designed for collision avoidance, traffic management, safety messaging. So I said, well, wait a minute, we've spent all this money and time on this to figure this out for cars. Why don't we use that exact same system to manage traffic? Because we're only going to be operated about 1,000 feet.
If that,
Right, and the range of these radios is about 3,000 feet. Right, so just 2 weeks ago, NASA invited us to sign up to a Space Act agreement with them to begin testing DSRC for air traffic management here in Detroit. So we now have not just the production piece and the vehicle piece, but also the infrastructure that's going to enable safe sequencing, separation of air traffic within urban environments using the rights of way that are already established over the roads and leveraging existing technology that has been tried and true as, as reliable.
I think that where the change in thought process has to come in is that these are not airplanes. They do not need to be regulated like airplanes or controlled like airplanes. We have to think of them as personal use vehicles that happen to lift themselves off the highway as opposed to being on the highway. And they have to be thought of as cars that are able to operate in the third dimension.
Right. We don't like to use flying cars, though. We hate that word.
Because
we don't think that makes any sense.
No,
right?
You're absolutely right. But I think conceptually, you have to think of it as a type of individual vehicular transportation that's vertical as opposed to operating on the surface of the road. And they're not, strictly speaking, airplanes. No, flying cars make zero sense because at best you wind up with a miserable airplane and a miserable car.
Right,
and,
exactly right.
Too much of a compromise to do it that way.
You just can't do it.
Yeah.
And you know, these guys that from time to time demonstrate an airplane and then you detach the wings and that they've got this little three-wheel thing and they say, oh God, somebody's done it. Yeah, somebody's done it. Doesn't meet any, it doesn't meet a single safety regulation anywhere in the world and therefore would be doomed to 25 miles an hour in retirement parks. Right. So, but again, the change in thinking is that this is not airplanes that have to integrate themselves in with the greater control system, and they'll probably be restricted to an altitude, as like John says, 1,000 feet. And then regular airplanes will obviously be deprived of operating at that altitude. And we just have to think of them as a different type of personal vehicle transportation.
Yeah, Robin, I'm intrigued. Both you and John have talked about making these electric. Why?
Well, first, I guess it doesn't have to be electric, as
Bob said, but you guys were talking electric.
Yeah. I think it has to do with that sort of extrapolation of what we're seeing in those vehicles.
Yeah,
right?
It's coming anyway.
Yeah.
Energy density, power densities are there.
And I imagine these would be far quieter than helicopters.
So our target is about 75 dB.
So put that in perspective.
I mean, the hum of a refrigerator.
A lot less than a Harley Davidson. Put it that way.
Very true.
But the conversation about the altitudes and where they're flying, I think, is very relevant, and it's I think as they're looking at the, and I don't want to get too infrastructure involved, but that really, to the point, is you don't want to try to operate all of that on, let's call it, the main traffic management system, because of the bandwidth requirements. It'll, in a sense, as they said, sort of clog it. But the ability to have that parallel network that can integrate, because there will be times when those two airspaces get close to one another. There will no doubt be challenges when things stray from where they're supposed to be, which we all know that happens, and the ability to reconcile that and deal with it. And one of the things I think is beautiful concept around the quadcopters is, if those that have operated their commercial drone at home is when you just want it just stops and hovers. So there's the opportunity to take a pause, to recalibrate,
and it'll just hover there.
Just hover there.
So you take your hands off the controls.
Well, you're not controlling it, but if it needs to, and it doesn't have to proceed in the way that, say, a winged aircraft does.
Just stop.
It can just stop and take a break and say, okay, I'll just wait my turn, or I'll wait till that gets out of the way. The idea that it adds a whole nother dimension of safety in the detect and avoidance space.
John, tell us a little bit about the craft that you're working on in this sense. How many people can it carry? Can it take their luggage? How far can it go? How fast will it go?
So the requirement for us to meet our customers' requirement is 4 to 5 passengers, 100 pounds of baggage, 150 miles an hour, and 60 miles of range. Right? So there are a few ways.
With a reserve.
With a 20% reserve, correct.
So the 60-mile, presumably you'd start out in a congested downtown area, let's say Manhattan in New York City, and you got to go to one of the local airports, Newark, LaGuardia, or JFK.
Correct.
You jump on one of these and you're there in what, 10, 15 minutes?
So you're looking at using like the Uber interface, right? And you're going to...
Uber is all over this idea as well.
So we are...
Why wouldn't they be? See, they get it.
Yeah.
They get it. It's just
they're leading it.
another form of car.
Yeah. Well, they see the problem, right? They're experiencing the problem firsthand with congestion in an urban environment. So the next logical sort of move is to move to the third dimension. So with respect to, you know, the use case, you know, an individual will, you know, request a vehicle. It'll put in its endpoint destination. It'll determine is it an air or a ground sort of scenario. And a vehicle will come and pick you up, take you to a vertiport, and then fly you to LaGuardia.
And what's something like this going to cost?
So right now the target is the cost of an Uber X ride. So about $2.50 a mile.
So the same, and Uber X is the,
Sort of the lower...
the cheapest.
Right. Well, it's lower.
Okay.
So the cheapest would be pooling.
Oh, okay. Yeah.
So we've done the math, and I'm happy to say that the math is working. So using current density technology, which is about 212 watt-hours a kilogram, you know, we can complete the mission. Now we're looking forward to 300 watt-hour per kilogram, you know, energy density. We're looking forward to that. I think that there's some great technology when it comes to, you know, hybrid, when it comes to, you know, fuel cell technology.
For much longer range.
Well, General Motors has got a great technology. It's they're opening up a fuel cell plant in Brownstown, which this thing is about the size of a V6 engine. It weighs about 210 pounds, and it can generate as much as 97 kilowatts per hour.
So it would be
which
perfect.
Is equivalent to a Tesla battery, which weighs 1,200 pounds.
Yeah.
So here's something that weighs a fraction of a battery that now we can take, instead of going 60 miles, we'll be able to go 180.
Yeah. Hey, look, with this, we're going to have to wrap it up. I'm afraid we're out of time. Fascinating discussion. I want to thank all three of you for being here. Bob Lutz, Jon Rimenelli, Robin Lineberger. This show is going to have to go on at another point. Too interesting.
Yeah, happy to have you.
Thank you, John.